Welcome back. Today we're going to be looking at section 5.7, which is inverses and radical functions. Just a quick note before we get started, this is the last section that we're going to learn of chapter 5, so I would strongly encourage you to go back and review some of the notes that we've worked on, practice the practice problems, and reach out to your instructor if you need help reviewing. This section has been a little more challenging and a little more tedious than the other sections, so I think it takes we should take extra caution with just assuming that we know the answers and really buckle down and try to learn some of these topics. So with that being said, let's get started and finish chapter 5 today. Our scripture for the day is the last time we did inverses, and we're just going to be reviewing a lot of inverses. I talked for a little bit about how a lot of the Bible and the kingdom of God is described as upside down or different or contrary to the way of the world. And I said in that time that there's a slew of Bible verses about this. And so here's another one. Where it just says, God resists the proud but gives grace to the humble. Therefore, humble yourselves under the mighty hand of God, that he might exalt you in due time. Cast all your cares upon him because he cares for you. And this comes out of 1 Peter 5, where God is describing how those who are exalted on earth will be humbled, and those who are humble on earth will be exalted. Just like many things, like the mountains will be leveled so that the valleys may be filled. Jesus has come to institute a new order and a new kingdom where the first shall be last and the last shall be first. So along those lines, we're going to invert what we've been doing and talk about inverse functions. So the first example, or the first try it, is just a review from the last section. And if you remember, how do you show that two functions are inverses? Well, we would just do f of f inverse of x, and we need it to equal x, where you compose the two functions or make it a composite function. And likewise, you need to go backwards and say, what is f inverse of f of x? And need it to be x. I'll leave you to try that because we've done a lot of we've done a lot of practice problems on composition of functions and inverse functions. And so you could compose those functions and check and see, are those two functions inverses of one another? But today's thing, we're going to talk about some functions where inverses work a little weird. Now that we have the skills of domain and range and restrictions, we can look at inverses with a fuller light. So here's an inverse function. And the first thing I'm going to do is make note of what this function looks like. It looks like the normal cube root function, which is that, but shifted to the left by 4. So I'll move it to the left by what we can assume is 4. 1, 2, 3, 4. And what you notice about that function is, first off, it passes the vertical line test, meaning it's a function, but it also passes the horizontal line test, meaning it's a one-to-one function. And because it's a one-to-one function, it is therefore invertible, or we're allowed to invert it. And so we can apply the properties of inverses without caring about the domain or the range or restricting anything, and we can just jump straight in and say, we need to switch x and y and solve. And so we switch the x and the y, and we solve. And so what we do first is we probably cube both sides. So we get x cubed equals y plus 4. And then we can subtract 4 from both sides and get x cubed minus 4 equals y. And then the very last step from the inverses section was to write it as an inverse by using inverse notation, which is f inverse x is equal to x cubed minus 4. And that's true for all real numbers. So the domain of that inverse is all real numbers, and that's the key thing that's the thing that we're going to key in on today, is that this is not always true for every function. Not every function is invertible, and some of them have to be worked on. For example, this try it 3, if you think for a second before jumping into the problem and try to graph the original function, we know that it's the parabola or the quadratic function, except it's been shifted up by 1. And so it's the quadratic function shifted up by 1, and you'll see pretty quickly that yes, that passes the vertical line test, but it does not pass the horizontal line test. In fact, it fails right there. Pick a spot. It fails right there, and therefore it's not one-to-one. And because it's not one-to-one, it's not invertible. And so before inverting it, we have to do what the problem does right here and set the domain equal to 0, infinity. and say, now if I take all of the negative numbers and restrict them or eliminate them and start my function at 0, then I'm allowed to invert it. Then I'm allowed to invert it because that restricted function is 1-to-1. It does pass the horizontal line test. And so they've restricted it for us, and now we can solve this problem. So we say y equals x squared plus 1, which means y minus 1 equals x squared, which means x equals y minus 1 square rooted. And then I'm switching x and y at the end, but that's okay. And now I'll say f inverse of x equals the root of x minus 1. And this is where we need to be careful, because we introduced a square root to our problem, so we have to pick whether it's plus or minus the square root. And we'll go to our domain to do that. We'll say, okay, our domain was 0 to infinity of the original function. And if we look at the graph on the left, the range was 1 to infinity, where it started at the y-intercept of 1 and worked its way up. And remember, so that's the f of x. And when we invert it, the domain and the range switch. And so now our range is 0 to infinity, and our domain is 1 to infinity. And so if we look at our range, our new range, which was our old domain, we can see that they're all positive numbers, which means we're going to pick the positive for our inverse function. And you don't have to write that plus sign. It's implied if it was left alone. But that's just a clue that, hey, I checked, and it was the positive version of the square root function because I checked the restricted domain and what that made the range in the inverse function. And I looked at my range on my graph to see which function fits it better, the positive version of the square root or the negative version of the square root. And so that's just an example of when some things don't have inverses and you have to restrict them so that they do. So here's another example. The square root function as the square root from 2x plus 3. Now remember, this had a domain restriction as well. It wasn't all real numbers that this was allowed to be. The inside had to be a specific thing, namely, the inside had to be greater than or equal to 0, which means 2x had to be greater than or equal to negative 3, which means x had to be greater than or equal to negative 3 over 2. So what was our domain in the original function? Our domain was negative 3 over 2, comma, infinity. And so that's our restriction. That's where we're going to allow x to be before we invert it. We can't let x be anything less than that. And then we'll just invert it like normal. Y equals the square root of 2x plus 3. Switch x and y. And so we have the square root of 2y plus 3. And we solve for y. So x minus 3 equals root 2y. Square both sides. So x minus 3 squared equals 2y. And then we'll say y equals x minus 3 squared over 2. But we're going to notice something about that. That was an answer that was a quadratic function. So x minus 3 squared over 2 is a quadratic function. And we didn't reflect an entire quadratic function. We only reflected the top half of a quadratic function. And so we need to decide, what does this domain make our new range? And so what we're going to do is we're going to find the range of this function by plotting it. And then we're going to see what that makes our new domain. So the range of this function, if we look at a graph, would have been there's no vertical shift. And so it shifts to the left by a factor of 2/3. And horizontally gets compressed by a factor of 2. But we can look at the range and say, well, it still starts at 0 and goes up to infinity. which means my new domain of my function, because the range and the domain switch, we say the new domain of this function is from 0 to infinity. Which for a parabola means you're only thinking about half the parabola. If a normal parabola, it looks like that, and we say we only want 0 to infinity, a new parabola looks like that. So there's our restriction coming into play. And it is important to think about these restrictions because not all functions have perfect inverses. Here's the last example. Now this one only has one restriction, which is kind of nice. It has x cannot equal 2. Remember, you look at the bottom, that's technically speaking a vertical asymptote. Because the bottom equals 0 and it doesn't cancel out to make a removable discontinuity. This one's going to be a little tougher, so follow with me as we do this. We're going to say y equals x plus 3 over x minus 2. We're going to move the x minus 2 over. Or no, first we're going to switch x and y. Remember, we're still doing inverses. So x equals y plus 3, y minus 2. And then we're going to say, I'm going to move that bottom over because nobody likes fractions. And I'm going to say, okay, well, now how do I turn 2 y's into 1 y? Well, I'll distribute that x, and I'll say xy minus 2x, if I distributed property that, equals y plus 3. And now here's just a little trick to get it to happen. Let's put all the y's on one side. So xy minus y equals, and then we'll move all the x's to the other side. 2x plus 3. All right, so all the y's are on one side now, and all of the x's are on another side. Now, the trick here is to say, how can I turn 2 y's into 1 y? And you might say, well, there's something in common. Can I factor out a y? And so if you have a red y out there, we have x minus 1 left over equals 2x plus 3. And now we almost have y by itself. If we divide by that x minus 1, we get y by itself. Zoom out because that was a little tedious. You can look at that as I rewrite it with the proper inverse notation. 2x plus 3 over x minus 1. And then I'm just going to make a note of, well, we can automatically see what x is not allowed to be, right? In my inverse, x can't be 1. Because the domain restriction on the bottom would say x is no longer allowed to be 1. And if we want to check and see, okay, so x's were y's in the original function, and y's are x's in the new function, watch what happens. If I take the old function and I say f of x equals x plus 3 over x minus 2, and I check what happens when y was equal to 1. So 1 equals x plus 3 over x minus 2. If I let y be 1, because that's the inverse function, I'm inverting that x to be, I'm inverting that bottom x equals not equal to 1 up here to be a y value now. And I'll solve this function by multiplying x minus 2 over equals x plus 3. I'll move the x's to one side. So if I move this x over, I get 0 equals, and if I move this 2 over, I get 5. And is that true? Is 0 equal to 5? No, so it looks like something went wrong, and that function was never allowed to be equal to 1. There was no number you could plug into x to make it 1. So when you flip that x and make it a y, there's no number on the inverse that you can plug and chug 1 for to get back to your original function. I know that's a little in the weeds, but what we're saying is x's and y's switch on inverses and original functions. And so if x can't be 1 in the inverse, that means that y couldn't be 1 in the original function. And all of that was just a check to see, is that true? Is it true that y can't be 1? And when we played it out and saw something bad happen, we said, oh, looks like y couldn't be 1 in the original function. And I think that's a pretty cool result. I'll go ahead and box the answer, though, of the inverse function with the restriction happening. And that will be all of Chapter 5. So I would highly encourage you to go back and look through the videos, look through the notes, practice some of the practice problems, and prepare yourself for the Chapter 5 test that's coming up. Best of luck studying, and I'll see you next time.